Okay, so let's start this new topic called portfolio analysis. Normally, the purpose of owning investments is to maximize your return and also to minimize the risk on those investments. Okay? Now, so what we want to look at now is how do you calculate the return on your investment and how do we calculate the risk of your investments. When you have many investments, we normally say you have a portfolio of investments. We want to look at how do you calculate the average return on your portfolio. You have many investments in your portfolio. What is the average return? What is the risk of those investments? Okay. But before we look at how to compute the return and the risk of a portfolio, we need to know how do we calculate the return and the risk of a single investment or a single security. So let's start by discussing how do you calculate the average return of a single security. How do you calculate the return of a single security? Average means the mean. Average means the mean return. Are you there? That's how we are saying average or mean return. Good. So to calculate the average, let me use an illustration. Suppose you are told a particular investment had the following returns over a period of maybe 4 years. You are given the year, you are given the return, which I want to assume is X. Okay? The return there, let us call it X. Year 1, year 2, year 3, year 4. Maybe you are told in the first year, your investment gave you a return of 10%. In the second year, the investment gave you 12%. In the third year, the investment gave you 14%. And in the fifth year, the investment gave you a return of 15%. What is the average or the mean return? We are saying the average is the same as mean. How do you get the mean return on your investment? What is the average return on your investment? So to get the mean or the average, which I am going to be using as X bar, the average, we shall be representing it as X bar. What you do, you get the total of these returns and then you divide that by, get the total of the returns and you divide that by the number of observations, which are the number of years. For example, here I will say 10 plus 12 plus return of 14 plus 15. I divide that by the number of observations, which is how many years? 4 years. Good. So what is the average return? So let me do that calculation for us. Let me do it now. Let's do that calculation. We want to see the average return. So the first year, 10% plus 12. 10% plus 12 plus 14 plus 15. That gives me 51. If I divide that by 4, that gives me a return of what percentage? The average return. If I divide that by 4, it gives me an average return of 12.75 cents. So that's what we are saying is the average return on your investment. The average return on your investment. Now, let me develop a formula that we shall be using to calculate the return on a single investment. Let me develop the formula. So we calculate the mean, which I am saying is X bar. We shall be getting the mean by taking the summation of X. X is what I was representing as the returns. Here you get the summation of X. You divide that by N, which is the number of observations. You divide that by the number of observations. That's how we shall be computing the return on, the average return on a single security or investment. Good. Now you know how to compute the return on a single investment. Now we want to talk about the risk. How do you measure the risk of a single investment? So we want to discuss what we call measure of risk. I've told you the objective of owning investment is to maximize returns and to minimize the risk. Now, assuming this investment gave you a return of 10%, 10%, 10% every year. So if it gives you 10% or a constant return every year, then we say that investment is risk-free. It has no risk because you are assured of getting 10% every year, 10% every year. What brings about the risk of an investment? What brings about risk? What brings about the risk is the deviation of the returns. How the returns are deviating from the average. That is what brings the risk. The deviation of the returns from the mean. From the mean. I've said if the returns were 10%, 10%, 10%, 10%, even the average will be 10%. Okay? So in the first year the return was 10% and the mean is 10%, there was no deviation. So there is no risk. But if, for example, your return is average 10% and in the first year you got a return of 5%, then there was a deviation of 5%. If in the second year you got a return of maybe 6%, the mean being 10, there was a deviation of 4%. Okay? If in the third year you got a return of maybe 15% and the mean is 10%, there was a deviation of 5%. So a risk comes in because there is a deviation of the returns. There is a deviation of the returns from the mean. How much is the deviation from the mean? That's what brings about risk. Okay? Risk is measured comes in because of deviation of the returns. Deviations of returns. They keep varying. They keep varying. Today you get 10%. Tomorrow you get 15%. The other day you get a return of 20%. The other day you get a return of whatever. Okay? So the more they deviate from and the average, the more risky the investment. The more they deviate those returns from the average, the more risk the return or the investment is. The less the deviation from the mean, from the average, then the less the risky the investment is. Are you following? The more the deviation from the average or from the mean, the more the deviation, the higher the risk, okay, of that investment. The less the deviation of the returns from the mean, the less the deviation, the less the risk of that investment. So the question is, how do we measure the risk of an investment? There are two ways of measuring the risk of an investment. And one way of measuring the risk is what we call the variance. You can calculate the variance of course, you can hear even the term variance means how it varies from a particular point, how the return varies. So you can compute what we call the variance. We normally use a symbol, theta square, for the variance. Okay? Normally use theta square for the variance. That is one measure of risk. We call it the variance. The second measure of risk is you can calculate what we call the standard deviation of that investment. The standard deviation. And of course, I hope you still remember your mathematics where you were saying standard deviation is normally the square root of the variance. Normally the standard deviation is the square root of the variance. But how do we calculate the variance of an investment? How do we calculate the variance? We have said variance means what? How it varies. The returns, how do they vary from the mean? That is the variance or the deviation. Okay? One measure of risk is to calculate what we call the variance. How do we calculate the variance? To get the variance, we shall be getting the variance, don't write, we shall be getting the variance theta squared by saying or by taking the summation of what we call x minus x bar. You get the square of that, okay? Then you divide that by the number of observations. Listen. So I'm first getting x minus x bar represents this symbol, x minus x bar, that represents the deviation. Like for example, our average return was what? 12.75. 12.75. It deviated from, that is the mean, sorry. The 10% I got in year 1 had a deviation of how much from the mean? It had a deviation of negative 2.75. Are you getting? That was negative 2.75. Maybe I could use a figure so that I get a round figure. Let me get a round figure so that I use it clearly. Let me get a round figure so that I use it clearly, so that we make it clean, so that it becomes clear. So let me make one of these. Let me make one of these 16. Let me make one of them 16. So this will be 16. That will be 52. 52, if I divide that by 4, 52, if I divide that by 4, this will come to 13. So your average return is 13. Now listen. So if the average return is 13, the mean being 13, in the first year I got a return of 10%. So there was a deviation from the mean of negative 3. That's what we are saying. Let me put it in form of a table now to get the variance. I first get the deviation. Listen, I first get the deviations. I first get the deviation. This is the year. Year 1, year 2, year 3, year 4. We have the return is 10%. Second year, the return was what? The first year, the return was 10, 12, 14, and 16. 10, 12, 14, and 16. That is our X. Don't forget. Then I want to calculate how it deviates from the mean. How it deviates, each of these returns, how does it deviate from the mean? So what I'll do, I'll have a column here called X minus X bar. Okay? Our X bar, we have said, is 13. So I take the 10 minus 13. I hope you can see that is negative 3. Then in the second year, my return was 12%. 12, this is, maybe I can put it here. This is 10 minus 13. That gives you negative 3. In the second year, it is 12 minus 13. That gives me negative 1. Are you seeing? In the fourth year, my return was 14%. My average was 13%. There was a deviation of positive 1. There was a deviation of positive 1. In the fourth year, my return was 16%. The mean was 13. There was a deviation from the mean by how much? By 3%. Once you get the deviations from the mean, you square them. Listen, you square them. So this will be now having another column here. We'll be having another column here called X minus X bar. This is another column called X minus X bar squared. So negative 3 times negative 3, or negative 3 squared, that is 9. That is 1. 1 squared is 1. This is 1. That is 9. Then once you do that, listen, you get the sum. You get the sum of those deviations squared. Are you getting? You get the sum of those deviations squared. This is 9, 10, 11, 20. So I get the sum of the deviations. That is 20. Listen. Then, now listen, I divide that 20 by what? By n. In other words, listen, it's like I'm getting the mean. Listen, it's like I'm getting the mean of the squared deviation. I'm getting the mean. This 20 is the sum of the squared deviation. This 20 is the sum of the squared deviations. If I divide that by 4, which is 4 years, I am getting the mean, are you getting, or the average of the squared deviation. That's how we are saying, if I take that, it will come now to 5. So our variance will be 5. Our variance will be how much? 5. So to get the variance as a measure of risk, our formula is get the variance as a measure of risk. Our formula is to get the sum of the squared deviations. The sum of the squared deviations, you divide that by n, which is the number of observations, Are you there? Good. So now you can do that. I was saying you can do that in form of a table, here, where I was saying when you take this is x, this is the return x. Okay, then we want to get another column for x minus x bar, which is the mean. So you get the deviations from the mean. Then you square those deviations. Listen, the purpose of squaring the deviations is to eliminate the negatives. Okay, you get the square of those deviations. Then when you get the square of those deviations, you get the sum of those deviations. Once you get the sum of those deviations, you divide that by n, which is our number of observations, which are 4 years. Okay, meaning I'm saying it's like you're getting the mean of the squared deviation, which I've said here. Therefore, standard variance theta squared. That's our variance. This is variance. Now we are saying variance, which is theta squared, will be given by summation of x minus x bar, everything squared, divided by n, which we have said our sum of the squared deviations is how much? 20. I divide that by 4. That gives me a variance of 5. You there? Good. Now, once I get the variance, listen, I can now get the standard deviation. I've already told you a short while ago, that standard deviation, which we shall be calling theta, in simple, we normally call it theta, it's the square root of the variance. That's how we determine the standard deviation. You just take the square root of the variance. And now our variance is 5. So you get the square root, which is the same as taking the square root of summation of x minus x bar squared divided by n. Are you there? Good. So you take whatever is the variance, I put the formula in the square root, then I get the square root of that variance. Good. So before we continue, let's put down something on what we have already said. Before we continue, let's put down something what we have already said. What we have already seen is how to calculate the mean of a single security. Is the summation of x divided by n. Get the mean of a single security. Are you there? Good. Then I've said to get the measure of risk, you either calculate the variance or the standard deviation. Those are the two measures of risk. I've said, how do you get the variance? Get the summation of the variance from the mean. Get the sum of the squared deviations. You divide that by the number of observations, which is this formula now. That is the formula for what? Variance. Are you there? Then I've said, get the standard deviation, get the square root of the variance. You just get the square root of the variance. So let's put down something, what we have already said. Okay? Good. Now, before we continue, let me say something. Before we continue, let me speak to some of you. Before we put down the summary notes. Some of you who are watching this video have not subscribed to my YouTube. So if you have not subscribed to my YouTube, please subscribe. Click that subscription button. Below there and subscribe. Are you there? Click the subscription button and subscribe. You can do it as you are watching this video. Okay? 2, please like the video. Click that like button to like the video. I hope you have understood something so far. Before we will continue, click the like button to like this video. Okay? Another thing is, Another thing is, for some of you who have friends who are doing financial management and they want to join our online classes. Some of you are friends who are looking for online classes. Tell them that we are offering online classes for financial management, like the one we are doing now for intermediate level. We also offer financial reporting of the intermediate level. We are also offering advanced financial reporting of the advanced level. We are also offering financial accounting of the foundation level, and the one of ATD1 and ATD2. We are offering those four subjects. So tell your friends that we are offering online classes for financial management of the intermediate, financial reporting of the advanced level, financial reporting of the intermediate, advanced financial reporting of the advanced level, financial accounting of the foundation level, and the one for ATD1 and ATD2. Okay, good. Now, if your fellow friends cannot be able to join the live class, then tell them they can buy what we call the pre-recorded videos. So that they watch the videos at their own free time, at their own pace. If they can't join the live class, then they can buy the pre-recorded videos where they get the videos for the whole syllabus. Then they can watch them at their own free time. Good. The other thing is, tell them that they can reach me on this number 0722 658875. That's my number. That if you want to reach me, you can reach me through this number 0722 658875 for more information, if they need more information. Okay, that's what I wanted to mention, that you can subscribe. If you are watching this and you have not subscribed, please do subscribe. 2, said click that like button. If you like my video, click that like button. Then I've talked about the subjects we are offering for online classes, that is financial management, FM, financial reporting, VAR of the intermediate, advanced financial reporting, advanced level, and financial accounting of the foundation level. Then we have said if they can't join the live class, let them buy the pre-recorded videos. Good. Then they can call me on this number 0722 658875. Good. So I think we can now put down something. We can now put down some notes before we develop the topic now. So the topic is portfolio analysis. Let's put down some summary notes now. Portfolio analysis. Portfolio analysis. Portfolio analysis. You can start with, have another subtopic below that. Average return of a single security. 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 When you have said that, copy this formula. Average return of a single security. Then you can copy this. Mean is equals to, copy that formula now. Mean x bar equals to summation of x divided by n. Summation of x divided by n. That's the average return or the mean. Okay. Then from there you can put down a simple example. I hope you have copied the formula. We have said the mean x bar is given by summation of x divided by n. Summation of x divided by n. Good. Then put down the form. Put down an illustration now. Put down this illustration. Put down this example. Example. Say this. Determine the average rate of return. Determine the average rate of return. determine the average rate of return from the following returns of security X. The following returns of security X. We have the column for the year, have the returns, said we shall call them X, year 1, year 2, year 3, year 4. So put it 20%, 25%, 28%. This is 28%. Then put this is 27%. Those are your returns for a particular security. Now we want to calculate the mean or the average. Mean or the average. We just come and see your mean. X bar equals to summation of X divided by N. Let's take our summation of X, that is 20 plus 25 plus 28 plus 27. We divide everything by 4. We divide everything by 4. So let's get the sum of X. Let's get the sum of X. So I take 20 plus 25 plus 28 plus 27. Whatever I'm getting, which is 100,000, I divide that by 4. That looks like exactly 25. So that is the average return. The average return on security is 25. Over a period of 4 years, you have got an average return of 25%. You have got an average return of 25%. Okay, good. Let's now go to measure of risk now. Now that you know how to compute the return of a single investment, the average return. Now we go to the next subheading, measure of risk. We have a subheading, measure of risk. A subheading, put it down, measure of risk. Measure of risk. Measure of risk. Measure of risk. Then you see this. You want to put down something there. Semi-V. What makes an investment to be risky? IV. What makes an investment to be risky is the variation. What makes an investment to be risky is the variation stroke. It's the variation stroke deviation of the returns. What makes an investment to be risky is the variation or deviation of the returns. Stop. Continue. Continue. If the returns are constant, over the years, if the returns are constant over the years, then the investment is risk-free. The investment is risk-free. If the returns are constant over the years, then the investment is risk-free. Another paragraph. The absolute risk of any security, can be measured by absolute risk of any investment can be measured by number one, variance. This is variance put in bracket theta squared of the returns. Variance in bracket theta squared of the returns. Then put down the formula. We have already discussed the formula. To get the variance, theta squared, you can just call it here, variance theta squared, we have said is what? Is the summation of the deviations x bar squared divided by n. Put down that formula. That's how we shall be computing the variance. Get the deviations first from the mean of x values, square them, get the sum of those squared deviations, and you divide that by the number of observations. You divide that by the number of observations. Okay? You divide by the number of observations. That's one measure of risk. Number two, standard deviation. Standard deviation, put in bracket theta. Then you can say this, standard deviation this is standard deviation equals to the square root of what? Variance. The square root of the variance, which we can say standard deviation theta is given by square root of summation of x minus x bar squared divided by n. Said it is summation of x minus x bar squared divided by n. Okay, good. Think now we can do an illustration on how to compute the variance and the standard deviation. To finish, we do an example now. Okay. I want you to write this. Example. Are you through with the writing of the formulas? I hope so. Then you say this. The following are the rate of returns. The following rates of returns were observed. The following rates of returns were observed from security X. Over 5 years. The following rates of return were observed from security X over the last 5 years. So have a column for the year 1, year 2, year 3, year 4, and year 5. Then you have returns. Let's call it X. So this is 20%. This is 19%. 17%. 13%. And 16%. Those are the returns over a period of 5 years. Then andika hapo kando required, or below that, required, calculate the standard deviation. Calculate the standard deviation. Calculate the standard deviation of the returns. Calculate the standard deviations of the returns. Good. Of course, we have said it's the square root of the variance. How do you get the variance? We said it is x minus x bar. X bar represented what? The mean. So automatically it means you first must get the mean. You must first get the mean. Let's do the calculation for the mean first. We need to calculate the mean. So andika hapo answer. Then you say determination of the mean, x bar. And we said the mean is given by mean x bar. We said the summation of x divided by n. Summation of x divided by n. So let's get the mean. Let's get the mean. So I can sum up. Let me add all this. 20 plus 19 plus is 20 plus 19 plus what? Plus 17 plus 13 plus 16. Divide that by 5. What does it give us? Want to get the mean of this. This is 20 plus 19 plus 17 plus 13 plus 16. This is 85. Divide by 5. It's 17%. So our mean is 17%. Now we can use it to get the standard deviation. Our mean is that. So let me have a column for the year. Want to prepare the table. Year 1, year 2, year 3, year 4, and year 5. Okay. Then we have the returns. Here, which was x. I copy them. 20, 17. No, not 17, 19. Then it is 17, 13, and 16. Then I have another column now. This is the column of x minus x bar. X minus x bar. So I can take 20 minus 17. That gives me 3. You there? 19 minus 17. That gives me 2. 17 minus 17. That gives me 0. You there? 13 minus 17. That gives me negative 4. Then finally, 16 minus 17. That gives me negative 1. Good. Then after that, I need another column now for x minus x bar squared. This is x minus x bar squared. So we square the deviations. So let us square those deviations. We have got some of the deviations as positive, some of them as negatives. So we square the deviations. This will be 9, 4, 0, 16, 1. Okay? Then we get the sum of those deviations. Get the sum of those deviations. So 9 plus 4 is 13. 13 plus 1, that is 14. 14 plus 16, that's about 30. Good. That being the sum of the squared deviations. That being the sum of the squared deviations. Now we get the variance or the standard deviations. So we get the standard deviation. Standard deviation. I told you theta is the square root of summation of x into x minus x bar squared divided by n. So I already have the what is inside. I already have what is inside the numerator there. That would be square root of 30 divided by 5. Square root of 30 is the sum of the squared deviation. Are you there? So it means now I'm getting the square root of what now? This is the same as square root of 6. 30 divided by 5 is 6. What is the square root of 6? That's about 2.45 to the nearest 2 decimal places. So now you know how to compute the standard deviation of a single security. Now you know how to compute the standard deviation of a single security. So finish, I want us to do a simple past paper question. Finish, I want us to do a simple past paper question now. Finish, I do a simple past paper question. Finish, I do a single past paper question. Finish, I want to project a question that I want us to do now. I hope you are through. Let me project a question. Let me project a question that I want us to do now. Okay, I've projected a question there. I've projected a question. That question number B, it's a question that came in August 2022. That question B came in August 2022. I want to read it. It says, August 2022, question 5B. It says, the financial expert has provided you with the following data regarding returns of company whatever shares for the years 2017 to 2021. You are given the returns there, the years, and you're given the return. Then you are told, required, calculate the risk of the company shares returns as measured by the standard deviation. So we are computing the deviations, the standard deviation of these returns. So let's do that now. Let's do that question now. We are computing the standard deviation. That is a question we are doing of August 2022. This is August 2022, question 5B. Okay? Let's do the mean first. We need to get the mean. So we come and say here mean X bar. We are calculating the standard deviation, but to get the standard deviation, you need the mean. So we said mean is equals to summation of X divided by N. So let me just add all those returns, divide that by 5. I add those returns, I divide by 5. That is the average. So our mean is 18 plus 16 plus 10 plus 6 plus 8. Those were the returns. I divide that by 5. What does it give us? Those were the returns. What is the mean? So 18 plus 16 plus 10 plus 6 plus 8, that is 58. 58, if I divide that by 5, so let me divide that by 5, that is giving me 11.6. That's our mean. Now we can use it to get the standard deviation. For standard deviation, let me prepare a table now. We need to get the column for the year. year 1, year 2, year 3, not year 1, year 2. There were 2016, 2017. Which other years? 2017 to 2021. 2017, 2018, 2019, 2020, and finally 2021. Then we come and quote the returns are, no, we can call it X. We were given the returns. Let me just copy them again. 18, 16, 10, 6, and 8. Now we want to get the deviations from the mean, X minus X bar. Now I don't have to write this minus this minus this. I think you now know. Our mean is 11.6. So I take 18. Maybe I can just put number 1. I put only one of them. 18 minus 11.6. What becomes the deviation there? So that you know what we are doing. That is 18 minus 11.6. I'm getting a deviation of 6.4. Then I take the second one, 16 minus 11.6. I'm getting a deviation of 4.4. Next one, 10 minus 11.6. I'm getting negative 1.6. Then next one, 6 minus 11.6, negative 5.6. Then finally, 8 minus 11.6, that is negative 3.6. Then I get the squared, x minus x bar squared. Let's get the square. This was 6.4, sorry, that was 6.4. So I take 6.4 times 6.4 again, that is 40.96. 40.96. The second one is 4.4 times 4.4 again, that is 19.36. Okay. Next one is 1.6 times 1.6 times 1.6, that's about 2.56. Next one is 5.6 times 5.6, that's about 31.36. Finally, 3.6 times 3.6, that's about 11.88. Then I get the sum of those squared deviations. Get the sum of the squared deviations. So let me do it. 40.96 plus 19.36 plus 2.56 plus 31.36 plus 11.88. I'm getting, let me repeat, there's something could be wrong. Don't know where I've gone wrong. All right, just a minute. Just a minute. It's like I've picked the wrong figure here. 3.6 times 3.6. Oh, I've done the wrong one. The last one. Listen. Listen. The last one is not 11. I mistook. I don't know how I got 11.88. 3.6 times 3.6 is, make that correction please, is 12.96. 12.96. Sorry for that correction. Make that correction please. So now we can add the total, 40.96 plus 19.36 plus 2.56 plus 31.36 plus 12.96 That gives me 107.2. 107.2. That being 107.2, now we can use it to get the standard deviation. Let me just put it in short. Standard deviation, theta equals to the square root of summation of x minus x bar squared divided by n. Summation of x minus x bar squared divided by n. Good. So now we can do the feeding, the data. Our numerator is 107 divided by 5, which is the number of years. Then I get the square root of everything. Let me divide that 107 by 5. I'm getting square root of 21.44. Square root of 21.44. What is the square root? That gives me about 4.63. Good, 4.63. So that's what the examiner wanted you to do. They wanted you to determine the standard deviation. To finish, I want to develop the topic now. I want to develop the topic. Finish, we develop the topic before we do a few more past papers. We develop the topic before we do some new other past papers now. Hoping you're through with the copying. Now you know how to compute the mean and the standard deviation. We are developing the topic. You now know how to compute the mean and the standard deviation of a single investment or a single security. We have not started a portfolio. Not yet. Portfolio, we say these are many investments put together form what we call a portfolio. We shall compute the return, the average return of a portfolio later. For now, just want to talk about how do we determine the return of a single security, the standard deviation of a single security. We shall apply them when we shall be coming to portfolios. Okay, good. I hope you are through now. I hope you are through now. Let me introduce something, but before I give it the subtopic, let me develop concept first by using a simple illustration. Let me develop a concept first by giving an illustration. Don't write. The following were the returns from a single investment over a period of 10 years. 10%, 10%, 12%, 10%, 12%, 14%, 14%, 10%, 12%, and 14. Let me see whether they are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. Now, again, listen, you may be required to get the mean and the standard deviation of this security. But what you can now see is that the returns keep repeating themselves. One time you get 10%, it's another 10%, another time 12%, you got it another many times. Meaning the returns have some frequency. We want to use some frequencies now. Instead of adding using the raw data, listen, instead of adding all this and using the raw data to get the mean and the standard deviation, you can use the frequency. You can use their frequency to get. Now, listen, if I may just start with the raw data, let me just add and get the mean first. Let me just use the raw data first so that I just mean, I explain to you what I mean. So don't write, I'm just explaining 10% plus 10 plus another 12 plus 10 plus 12 again, plus 14, plus 14 again, plus 10, plus 12, plus 14. That gives me a total of 118. If I divide that by 10, gives me an average of 11.8. That's the average. But I want us to arrive at the same 11.8 by using the frequencies. Okay? Look at this now. 10, this return of 10, it occurred how many times? It occurred how many times? 1, 2, 3, 4. So out of 10 times, it occurred 4 times. So the frequency was 4 out of 10. Don't write. That was the frequency. There is another return, 12%. How many times did it occur out of 10 times? Is 1, 2, 3 times. Okay? The frequency of 12% as a return was 3 out of 10 times. That was the frequency. Okay? Good. Then there is another return you got of 14%. How many times did it take place? 1, 2, 3. 3 times. Okay? So the frequency of 14% was 3 out of 10. Now listen carefully. So you may be asked, what is the probability? Listen to this now. What is the probability that I will get a return of 10% on my investment? Maybe next year. What is the probability? If this has been the history of this investment, what is the probability that I'll get a return of 10%? So I'm looking for what we are calling probability here. If I got 4 out of 10 times a return of 10%, 4 out of 10 times I got a return of 10%. So there is a probability of 0.4. Are you getting? 4 divided by 10, there is a probability of 0.4 or 40% probability that I'll get a return of 10%. Are you there? What is the probability that I'll get a return of 12%? If 12% took place 3 times in a period of 10 years, so what is the probability that my next return will be 12%? It is what probability? 0.3. 3 divided by 10 is 0.3. So that is the probability. Okay? That is the probability. So in other words, we are saying this probability, you can see they represent the frequencies. Are you there? Good. 14 occurred 3 times out of 10. 14 as a return occurred 3 times out of 10 years. So the probability that I may get a 14% return next time is what amount? 0.3. Good. Now listen. So you can use probability. You can now use probability to determine the return, the average or the mean return of this. So to get the return where there are some probabilities, that's what I'm introducing now. Listen, where you are not given the frequencies, the examiner will not give you these frequencies. He will just tell you, listen now, I'm developing now. I've managed to get what I wanted. I started with the raw data there of 10 years. Then I had to identify the frequencies in which these returns are occurring. Then I have explained and said the frequencies also represents the probability. 4 out of 10 times is a 40% chance that I might get 10% return. 3 out of 10 means there's a 30% chance that I might get a return of 12%. 14 return occurred 3 times out of 10. So there's another 30% chance that I might get a return of 14%. Good. What I'm trying to say, Sometimes the examiner just gives you the following data. He tells you the return of this investment was 10, 12, 14. And the probability of this returns was 0.4, 0.3, 0.3. Calculate the average return. Calculate the average return or the mean. So, I have just told you, probabilities represent the frequencies. So to get the mean, you will just take, this is X. This is probability, let me represent it by P. What you will do, you will multiply X. You will multiply X by P. Let me just use XI or XI to represent each return. Multiply by each probability Pi. Okay? So like in the first one, 10 times 0.4, that will give me how much? 4. 12 times 0.3, that will give me 3.6. 14 times 0.3, what will it come to? That will give me 4.2. I think so. Let me do it. I think I'm right. 14 times 3. 14 times 0.3. Yes, 4.2. Then you get the sum of this. The last one is 0.8. Then I take 7, 11. Good. Listen to this now. I hope you are watching. I've got the mean, which is the sum here. Sum of X bar, no, X plus times Pi. When I take the sum of, let me just call it sum of X times Pi, which is this 11, I get the same mean. Listen, I get the same mean I got when I was using the raw data. Are you watching? I get the same mean I got when I was using the same raw data. So in other words, we are saying, when the examiner gives you the probabilities of a particular return, then it is the same as the frequency. 4 out of 10 times. Meaning, it's like you are adding the same times 4, times 4, times 4, times 3, times 3, whatever. Are you there? Good. So I've shown you now, listen, I've shown you how to calculate the mean where you are given probability. So to get the mean here, we shall be taking mean where there are probabilities. It is the summation of X times Pi. Summation of X times Pi. This time you don't divide because the frequencies were already dividing. 4 divided by 10, 3 divided by 10, 3 divided by 10, and so on. So this time you don't divide. It's already divided. When you are getting the frequencies, you took everything and you divided by 10, 10, 10, 10. Otherwise, you can see when I was using the raw data, I divided all the sum of those returns by 10. But now, when I'm given probabilities, I don't divide by 10 because to get the frequencies, I was taking 4 divided by 10, 4 divided by 10, 4 divided by 10. And those same frequencies are the ones which give me the probability, the chance being 40%, 30%, or 0.4, and so on. Are you there now? Good. With that idea now, let's put down another subheading now. That idea now, let's put down another subheading. Good. Hope you have understood there. So, andika subheading, expected stroke average returns. Put it down as a subheading, expected stroke average returns of a single security, with probability. With probability. That means where the examiner now gives you probabilities. I've said expected is also known as the mean. Expected or average return of a single security with probability. With probability. Then you can copy this formula now. You can now copy this formula. So you can say mean X bar equals to summation of x times pi, where x is return of security, and pi is probability of the condition, occurring. Good. Finish. That's what I wanted you to know, because some questions don't give you the frequencies. They don't tell you 10% occurred 4 times, 12% occurred 3 times, 14% occurred 3 times again. No. Instead, they give you the probabilities. So I've said probability is the same as the frequencies. Okay? Good. So with that idea now, I want us to put down an example. on how to compute the mean where you are given probabilities. Of course, we have already done an illustration. Just want to put it down as a simple example for the purpose of your notes. So, andika example. Then you say this. Calculate the expected return. Of the following security. Given return as a percentage, you're given probability. We have 15, 18, 20, 25. The probability of 15 occurring is 0.2. The probability of 18 is 0.3. The probability of 20 is 0.3. And the probability of 25 is 0.2. We want to calculate the mean or the expected return. Good. That one I just do a table. Simple. Come and see your answer. This is the return. That is x. Then we have probability, pi, and I want to get the product of those two. That is x pi. This is 15, 18, 20, and 25. Our probability was 0.2, 0.3, 0.3, and 0.2. What is 20% of 15? That's about 3. 30% of 18. 5.4. This is 6. 30% of that is 6. 20% of 25, I think is 5. Let me calculate. Yeah, it's 5. Then we get the sum. That will be the mean. This will be 3 plus 5.4 plus 6 plus 5. That's 19.4. Come and see your mean. X bar, which is the same as summation of x pi, is equals to 19.4. Good. That is it. Now you know the mean. Now you know how to get the mean with probability. Let us now do the standard deviation. Now we want to do the standard deviation. We shall borrow the formula for standard deviation. It's only that we are bringing in the concept of probability. Of course, don't forget, get the standard deviation. It's like you're first getting the variance. How do you get the variance? You get the deviations from the mean. Listen, you square them. That's what we are calling the sum of the squared deviation. Okay? This time, listen to this now. This time, you multiply by pi, probability. Good. So let me, if I may to do this, let me just explain. Let me just explain first. We have the returns here, which we are calling x. We have the probabilities here. I have said you have already computed the mean. You will get x minus x bar. That's obvious. Are you there? Then you will square them. X minus x bar squared. You will get them. Don't write. This time, we are having an element of probability. This 0.3. So you will have another column of x minus x bar squared times its probability. Good. So to get the variance, listen, to get the variance, I told you variance theta squared. This was variance. What was the formula? We are saying it's x minus x bar squared. Listen, I divided by n last time. Listen, I divided by n last time, but this time I don't divide by n because I told you probability is the frequency. When you are getting those frequencies, you kept dividing by 10. That is the formula. Listen, that is the formula O. But this time, you will multiply that by pi. Okay? We are adding only the element of probability. So the formula is like the same, but this time you don't divide by n like I did to get the variance. Where there were no probabilities, I was getting the summation of x minus x bar squared. I was dividing by n. Are you there? But this time I'm saying you don't divide by n because to get the frequencies, you are dividing by n. But then we are now bringing in the element of probability where we have the frequency that was being divided by. Good. Then of course, listen, get the standard deviation theta, just the square root of that. It will be summation of x into x minus bar squared pi. You get the square root. That will give you the standard deviation. So let's put down the formula. Let's put down the formula now, or we do an illustration now. Let's put down the formula or a subheading, sorry. Put down a subheading, standard deviation. Put down a subheading, standard deviation with probability. Standard deviation with probability. Standard deviation with probability. Standard deviation with probability. Then you can start with the variance. Theta squared is equals to summation of x minus x bar squared pi. Summation of x minus x bar squared pi. Okay? That's probability. Then I come and say, but I'm looking for standard deviation. We come and see a standard deviation. Standard deviation, which is theta, is equals to the square root of what? Variance. Where you can say it's the square root of summation of x minus x bar, everything squared times pi. Good. Copy that formula. Then we use it to do the calculation again. What that formula, then we use it. What that formula, standard deviation. So it's the same concept we borrowed from a single investment. We had to get the deviation, to get the variance. It's only that we are now adding the element of PI, that is the probability. Then, of course, to get the standard deviation, it's the square root of the variance. Finish. I want us to do a simple illustration. I want to do a simple illustration now. Okay, I hope you are through. So copy this example, copy this example, copy this example, example. Copy this example. The expected return of a security X are given below. The expected return of a security X are given below. So let's do the table again. We have return, which is X. This is as a percentage, 15, 18, 20, and 25. Then you have probability, which I'm calling PI, is equals to 0.2, 0.3, 0.3, and 0.2. Okay? So required, below that, required, calculate the standard deviation. Calculate the standard deviation of the return. Calculate the standard deviation of the return. First, you know you must compute the mean. First, you know you must calculate the mean. So let's compute the mean first. Calculation of mean X bar. Let's put it in the form of a table. We have return X. We have probability PI. Then we shall have X times PI. Our return was 15, 18, 20, and 25. The probabilities was 0.2, 0.3, 0.3, 0.2. What is the return? This is 3. This is 5.4. This is 6. And this is 5. This gives me 4 point. This is 8, 14, 19. That's our mean X bar. That's our mean. Now we know the mean. Now we know the mean, so let's use it to get the standard deviation now. Let's use it to get the standard deviation. Now you have the mean and get the standard deviation. Let me prepare a table. We have a column for return, a column that is X. We have a column for X minus X bar, the deviation from the mean. Okay? Our R was 15, 18, 20, and 25. We now know how to get the deviation from the mean. I don't have to keep repeating them. Now you know how to get the deviation. Our mean was 19. So I take 15 minus 19.4. That gives me negative 4.4. This is negative 4.4. Second year, it is 18. Now, second return, 18 minus 19.4. That's negative 1.4. Then we go to 20 minus 19.4, that is positive 0.6. Then we go to the last one, 25 minus 19.4, that's 5.6, positive 5.6. Then I square the deviations. I square those deviations. Okay? When I square those deviations, that is 4.4. That is 19.36. Next one, 1.4. That is 1.96. 0.6 times 0.6, 0.36. 5.6 times 5.6, that is 31.36. Then I multiply them by the probability. What is the probability? 0.2. This is probability Pi. 0.2. This was 0.3. 0.3. Think so? Yes. And the last one was 0.2. So I come and say here, x minus x bar squared Pi. So let's multiply them by the probabilities. That is 19.36. 19.36 times 0.2. That is about 3.8. 3.872. Second one, 1.96 times 0.3, that is 0.588. 0.588. Next one, 0.36 times 0.3. That is 0.108. Finally, 31.36 times 0.2. That is 6.272. Then I get the sum of those square deviations. Let me add them. 3.872 plus 0.588 plus 0.108 plus 6.272. That gives me 10.84. Good. Now we can get the standard deviation. Standard deviation, theta squared, I told you is the summation, a square root of summation of x into minus x bar, everything squared times the probability. So already I have that. What is inside the bracket is 10.884. So I just get the square root of it. Square root of 10.48. Yeah? Good. Because I've already done what is inside the calculation, the formula. Already done that calculation, which was giving me the table. So I just get the square root of 10.84. This gives me 3.29. That's our standard deviation. Finish. I want to touch on something small. want to touch on something small now. Finish. I want to touch on something small now. Finish. I touch on something small. We now know how to calculate the mean. Now how to calculate the standard deviation. Finish if you are still copying. Okay. Now listen. For example, let me explain. For example, from this investment we have just done, it had a return of how much? It had a return of 19.4. Listen, it had a mean of 19.4. That was X bar. Our standard deviation theta was 3.29. Listen, you may want to know, what is my risk per unit? Now listen, risk is measured by what? Standard deviation. Don't forget, we looked at the measures of risk and we said there is a variance and there is standard deviation. Okay? So what is my risk per unit of return? You may want to calculate that amount. What is my risk per unit of return? To get your risk per unit, this is what I'm calling it, risk per unit of return. Don't forget, return is the mean. From that statement, of course, you should be able to say risk per unit. It means you take the standard deviation, you divide that by the mean. That will give you, you are taking the denominator being the mean. You are dividing by the risk. What is the risk per unit of your return? Like for example now, this will be 3.29 divide by 19.4. That looks like 0. What? Let me look at that. What is my risk as a unit, or my risk per unit of return? My risk per unit of return. This would be 3.29. Divide that by 19.4. This will be 0.17. Let me put it in terms of that. 0.17. Now listen, what does it mean? I have said we are looking for the risk per unit of return. Risk per unit of return. So this tells me, listen, to earn 1% return. This is the interpretation. To earn 1% return, there is a probability of 17% risk, or the chance, or the risk to earn 1% return. Don't forget the return. We are calculating the risk per unit of return. I've taken the return to be the denominator. For me to earn 1% return, there is a 17% chance of getting a 17%. 0.17 is a same as 17%. To get 1% return on my investment, there is a 17% chance or risk of getting there is a 17% risk of getting a 1% return. Listen, this formula of taking the standard deviation, you divide that by the mean, that formula gives us what we shall be calling the coefficient of variation. The coefficient of variation, in short, we normally call it CV, coefficient of variation. Okay? And we are saying this coefficient of variation is also known as the risk per unit of return. The risk per unit of return. And we are saying to get this coefficient of variation, we shall be taking the standard deviation. You divide that by the mean x bar. Divide that by the mean x bar. Okay? Good. So let's put it down now. Let's put it down. Have a subheading, coefficient of variation. Put it down as a subheading, coefficient of variation. Coefficient of variation. Then you say this. This is also known as coefficient of variation. This is also known as risk per unit. Risk per unit of return. 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 Or relative risk. Some questions just tell you calculate the relative risk. Relative risk. We have said coefficient of variation is also known as risk per unit of return. Risk per unit of return. Then you can say now, copy the formula in full now. You can say your coefficient of variation, and put in bracket CV is equals to standard deviation, theta, divide by mean x bar. Divide by mean x bar. Standard deviation, divide by mean x bar. Good. That's how you get the coefficient of variation. I want us to put down a small illustration. Example. Copy this if you are through with the formula. Semi-IV. Security X as an average rate of return. Security X as an average rate of return of 20%. With a standard deviation. Of 6%. With a standard deviation of 6%. Calculate. I've said security X as an average rate of return, of 20% with a standard deviation of 6%. Calculate the coefficient of variation. Okay. This is simple. Let's now calculate it. Come and just say your coefficient of variation is equals to standard deviation, theta. Let's just put the formula in summary. Theta divided by mean x bar. You now know what these symbols represents. Our theta is 6%. Divide that by 20. What does it come to? 6 divided by 20 is 0.3. So to earn 1% return down there, we are saying there's a 30% risk return chance. There's a chance, 30%, for you to earn 1% return, which is the denominator. There's a 30% chance. Maybe you can put it, even that in a statement. Put down that in a statement. This means to earn 1% return. To earn 1% return, to earn 1% return, earn 1% return, there is a 0.3, there is a 0.3 risk chance. Risk chance. There is a 0.3% risk chance. There is a 0.3% risk chance for you to earn a 1%, which is the denominator. There is a 0.3% risk chance. Okay? Good. I think now we can stop there for today. We pick it up from there. What we shall do next time, we shall now discuss the portfolio. Now you know return of a single security. Now you know standard deviation of a single security. Next time, we shall now discuss how to compute the mean of a portfolio, a group of investments. How do we calculate the standard deviation of a portfolio? Okay? Now to calculate the coefficient of variation also. Are you there? Good. So let's stop there for now. We pick it up from there next time. But before we leave, let me remind you, I told you, please, if you have not subscribed, you are watching this, if you have not subscribed, please subscribe to my YouTube channel by clicking that subscription button. Are you there? Good. Also said, please click the like button, like the video. I hope you have enjoyed the class. Hope you have enjoyed the class. So click the like button to like the video. Good. 3, I've told you, tell your friends that we are offering the following subjects, online classes. One is financial management of the intermediate level, financial reporting of the intermediate level, advanced financial reporting of the advanced level, and financial accounting of the foundation level, and the one we said of ATD1 and ATD2. Then I told you, tell them if they can't join the live class, then they can buy what we call the pre-recorded videos, where they can watch the videos at their own free time, at their own pace. Okay? That's what I said. Then I said, if they want to reach me for more information, you can call me on 0722 658875. 0722 658875. Good. That's what I said concerning the online classes. You can tell your friends to join our online classes. Okay? So please recommend to them they join. Hope you have subscribed. Hope you have liked the video by clicking the like button. Good. See you next time. Bye for now. See you next time. Bye for now. Yes.